Okay, so this is going to lead into helping us with what you probably heard people talk about, unit circle. Okay, well, we talked a little bit about it. We labeled some of the angles back on the first day. Then we're going to actually look at the trig ratios in the unit circle. So this is going to help us a little bit. So there's a circle with center 0, 0 and radius r. So this is just any circle. The point xy is on the terminal arm of an angle, standard position angle theta. So it starts here and ends here. That's a point on that terminal arm. If we join that point with a vertical line down to the x-axis, it forms a right triangle. Okay? It says label the sides of the resulting triangle with x, y, and r. So we've already done r, the radius. So this side would be x, right? Because that point is xy, and this is your x-axis. And so from 0 up to there, that's going to be y. Okay? It's based on that point. You could have numbers, but in this case, we just have a general case. So the trig ratios of theta, sine, cosine, and tangent, can be stated in terms of the sides of the right triangle.
Yes.
See?
She knows. Oh, that was so funny.
Eric, you want to give me one?
Sure.
Okay.
Sine is y over r.
Good.
Cosine is x over r. And tangent is y over x.
Good. Okay. So rather than back in that 10, we often said opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. More frequently, we're just going to use x, y, and r. Okay? Because we're going to take whatever triangle it is and think about where it would be in a circle. Okay? These we call the primary trig ratios. Okay? They're the basics. And other ratios can be used from them, and also some identities, etc. But sine, cos, and tan, they're on your calculator. They're the primary ones. The reciprocals of those are also important, and they have their own names. Sine, cosine, and tangent. The reciprocals of them are cosecant, secant, and cotangent. Okay? So sometimes students have difficulty remembering sort of which matches up.
Why would you not have a reciprocal of cosine? Why would you not do that?
I didn't invent them, so I don't know. But here's how you can remember. So each pair has a code. So sine, the reciprocal is cosecant. So one of those two has a code. Cosine has a reciprocal function of secant. One of them has a code. So one of the two starts with a C. Tangent has a reciprocal of cotangent. One of the two starts with a C. Okay? So that's a little bit of a trick to help you remember. So if you're asked to find the reciprocal function of cosine, you're not going to choose cosecant because they both start with C. Okay? So tangent's easy because it's got tangent in it, right? Tangent and cotangent. So when I'm saying these, I don't want to hear you say sin of theta. Okay? Math is not a sin, first of all. And it's short for sine, S-I-N-E. And there's no extra, so we don't write the E, but it's just as easy to say sine as sin, and the ratio is sine, so we're going to say sine. Here, you can abbreviate this. I abbreviate it to cos. Some people say cos. Again, cosine is how you say it. So same amount of energy to say cos as it is to say cos. So I might as well say something that makes sense. Cos. So the abbreviation is cos. I don't abbreviate this because it would be like, which is really hard to say. I usually just say them out. Again, I don't say cot really, I say, and then cot here, so I say cotan. So really, the primary, you can abbreviate, and the reciprocal, I say the words.
What do you do for the hyperbolic integration? You say like cot
I think so.
10?
Yeah, right? Or tanning. Okay, so if we're taking the reciprocals, this is the reciprocal of sine. So if sine was y over r, this is going to be r over y. If cos was x over r, then secant will be r over x. And then cotan is how I would abbreviate that without the gen. So cotan, and we know that's right? So this one is the reciprocal, so that was y over x, so this would be x over y. Okay, we don't go 1 over y over r. We simplify that into a single ratio. Okay. All right, so that's just to summarize. So this is something important to look at, okay? XY lies on the terminal arm of the standard position angle theta. That comes from the Pythagorean theorem, right? So if I look at this triangle here, x squared plus y squared equals r squared, okay? That gives you this point here. There's your xy. That gives you every point on that circle. So that is your equation of a circle. Any circle. So just know that. We used to spend a whole unit on circles and ellipses and hyperbolas in math, what used to be called math 30 here.
What? Math 30 here?
Yeah, it used to be called year 30, as opposed to 30-1. And so we used to do that with the curriculum change. So you'll do more of that in university. Okay? But that for sure you should realize.
Is that where x squared plus y squared equals 1? That's the unit circle.
Correct, yeah. So this is just a summary. Just summarize that. You don't have to know. Okay, so now we did some similar to this back in math 10, but we kept it into certain quadrants. Okay, now it's going to be in many quadrants. So the point -2,5 lies on the terminal arm of the standard position angle theta. State the exact values of the primary and reciprocal trig ratios. So I always suggest doing a little sketch. So you make sure you know what quadrant it's in, and you visualize that. So there's your initial arm. -2, 5, that's -2 for x, 5 for y, so it's going to be terminal arm something like that. So -2, 5 is that point. So there's your angle, theta. Okay. From there, we need to draw a vertical line down to the x-axis, whichever x-axis is closest. In this case, that would be your triangle. Okay? So now when we find the trig ratios, we're using it in that diagram in this triangle. We call this the reference triangle because that angle there is the reference angle. Okay, so you call that triangle the reference triangle. But trig now, even though back trig, when we use sine, cosine, tan, back in math 10, they were always positive values. They were representing measurements. Now, there's negatives as well. So they're actually representing a location. Okay, so is it in the x value is negative? That means it's going to be in the second or third quadrant. Y values negative is going to be third or fourth. So that negative is telling you what quadrant it's going to be in. Okay, so in this case, this value is positive 5, and this is negative 2. Okay, so we're going to have sine of theta. Okay, and then we need to get R. Okay? So now for R, you set in here. So R is always a measurement, it's always positive, but X and Y could be negative because that's telling you of the location.
You get a negative R value than something on.
Correct.
Or you're dealing with imaginary numbers, still doesn't work. No,
Always positive.
wait, so then how do you trig stuff in calculus if you don't have calculators? Like, if it's not the exact value of ratios.
Yeah, you do some tricks, but it's all exact
Like,
value.
they're not thinking, like, what sine of, 2 pi over a billion, and like,
Yes. No. So 5 squared plus 25 plus 2 squared is 4, so that's root 29. Okay, so rationalize the denominator. Always positive. Okay, so the radius of the circle is a measurement, so it's always positive. Whereas X and Y, it's always negative. Now there will be times where maybe you don't rationalize, certainly if you're doing some other work from there, but most times we do. Yep, sure. Oh, yeah, I don't know.
it's pseudo.
It's a Monday.
It's a pseudo Monday.
Yeah. It's a Tuesday that feels like a Monday, so I think it's messing me up. So those are the primary. I wrote out these because to get the reciprocal, it's easiest to go from this one first. So I'll just do it. So this will be cosecant. So that's going to be root 29 over 5. And this is going to be secant. Negative root 29 over 2. And then cotan is going to be negative 2 over 5. So just keep the negatives out front. Don't keep them in the denominator. Even though that's, where they come from, perhaps. Okay, so that one we were given the coordinates of the point. Now we're given the actual ratio for sine of theta. There are two possible places where that theta could be. Two places where the terminal arm could be that would give that same sine ratio. But it gives you a hint that it has to be in quadrant 4. Oh. Okay, so says theta is a quadrant 4 angle. So something like that maybe. So here, quadrant 4 angle, that's theta. And so now when we draw our reference triangle, we go up to that x-axis. Okay, and then think about sine ratio. Sine is y over r. R has to be positive. So in this case, y would be -2 and r would be 3. So we already know, so this one, sine of theta is -2 over 3. Cos of theta, we need the x value. So now we use the Pythagorean theorem to find x here. So x squared equals the hypotenuse squared minus the other side. So 9 minus 4 is 5. X equals, it could be, x can be positive or negative. So solving this, it could be positive or negative √5, but it's in quadrant 4. So it has to be positive here. So therefore, x is positive 5, so quadrant 4, positive √5. So that means this. Okay, then tan is going to be -2 over √5, and then we'll rationalize that. And then our reciprocals. All right, so then get your calculator out. So use your calculator to determine the 4 decimal places, the values given there. So take a look at it. If it's got a degree symbol, your calculator needs to be in degree mode. So always check mode key, make sure it's in degree. And this is cosecant. There isn't a button for cosecant. So this is the same as 1 over sine of 35 degrees. So you can do that. So 1 divided by sine of 35. Okay. You could do, well, fraction form. You could do 1 over sine of 35. Okay. If you calculate sine of 35, okay, then you could actually take the reciprocal, which on the graphing calculator means x to the -1. So this key here, this button here, and you'll get the same thing. That takes the reciprocal.
Not sine to the -1 of that. That would be something. Yeah, not sine to the -1 of that. Sine of that.
Right, you can't split it up in the calculator. So the notation, yeah, that would be this. And that's on the, let's convert. as opposed to this is reciprocal. Alright? Okay, next one needs calculator to be in radian mode. So change it, quit out of it. That's a reciprocal of cos, folks. Gavin? You have a question? Okay. Cos of 5 pi divided by 6. Oh, 6. Okay, and then again, reciprocal of that. Okay, or you can go 1 divided by cos of 5 pi over 6. Okay, cotan is the reciprocal of tan. When we get into more trig, where we do things like identity and doing proofs, really, cotan, we think of it, first of all, as cos over sine. Because tan is really sine divided by cos. And so we're going to end up, rather than taking a reciprocal of tan a lot, we'll go right to the definition of sine and cos. But for the purposes here, just go 1 divided by tan of negative 2 pi over 3. Notice how even though I have the fraction capability, for something like that, it's just faster to put it in as a division statement. For some reason we skipped 7, or 7's at the bottom, the numbering got messed up there. So the point 43 lies on the terminal arm of standard position angle, determine theta. If theta is between 0 and pi over 2. So again, you can do a little sketch. Okay, point 43. So that's kind of obvious that it would be between that anyway. So for 3 would be probably something like that. So this will be 4, this will be 3. Okay, so determine theta. So take a look at it. Which is the easiest trig function to use? Tangent, right? If you want to use sine and cos, you need to do some other work. So let's use tan. So tan theta is 3 over 4. So remember back to math 10, if we're solving for an angle, we use the inverse operation in our calculator. And this says theta is between 0 and pi over 2, which means we have to use radians. So mostly check, it's in radians. And then we go second tan. So second tan has that -1 here, right after the tan, which means inverse tan. Means you're finding the angle, as opposed to that -1 I used in the last calculation. It was outside of it. I didn't say what to round to. So I'm going to go to 3 decimal places. Again, because it's radians, you don't want to, you can put radians, rad. Okay. This is in degrees. So you're going to do the same thing. So basically, given most of the newer calculators, you can just do this. Change it to degrees. Okay. If you have the ability to go up past the last answer and copy it out, then enter on that and it'll give you the degree order. Okay. Or you can take this radian answer, and remember you're converting to degrees, so multiply by 180, divide by pi, you get the same thing. And again, it doesn't say what to round to, but we're going to do that. Okay, I'm going to give you a couple minutes to fill in the chart, number 7, because you can use your calculator. Okay, so sine, cos, and tan of 30, 150, 210, 130. We'll see something interesting. Okay, so you should have found those values. Within each column, the absolute value of the values are equal, right? So if you were to make all of them positive, they'd all be the same. Take a look at these angles here. So this is 30 degrees in quadrant 1. 150 is in quadrant 2 with a reference angle of 30 degrees. This is in quadrant 3 with a reference angle of 30 degrees. This is in quadrant 4 with a reference angle of 30 degrees. So the reference angles are all the same. That's why the actual ratio, the number part, is the same. And then whether it's positive or negative is a location. That tells you what quadrant it's going to be in. Okay? So when you think about it, so we'll go through the questions actually. I'll do it faster. So what do you notice about the ratios in each column? The absolute value of them are equal. Oh. Okay. Okay, what do all of the angles have in common? As I said, the reference angles are all the same. Okay, so that means the triangles, wherever you draw it, they're all the same triangle. Just a different location, and then the x and y values could be positive or negative because of that location. Okay, so let's think about here. If the terminal arm lies in quadrant 1, what do we know about the sine ratio? So sine is y over the radius for the hypotenuse of that triangle, which is always positive. So in quadrant 1, if I do a quick sketch here, hey, guys, quiet. So if I have a reference angle, the same reference angle, okay, so here, the triangle formed there has a positive y value over r, so the sine, SIGN will be positive. Okay, in quadrant 1. If now it's over here, actually, I'll just do this, like this. Rotate it this way. The y value is also positive, right? So that triangle will have a positive sine ratio. Here, the y value is now negative. So my y over r will be negative. Okay, folks, can you stop talking, please? If you know it, go on. Next one here. If you know it, go on and close your mouth. Okay, this one, y is negative. Okay, then if you think about close, back into the first quadrant, here my x value is positive. Everything in the first quadrant will be positive. But as I go here, my x value is negative. So adjacent, or x over r, will be a negative value. So this will be positive, this is positive, all of them. But cosine now, this will be negative in quadrant 2. Oh, sorry. Down here, the x value is still the same. It'll be negative. But then again over here, we're back to a positive x value. Okay, then tan, positive here, positive over a negative, which is negative. Here, a negative divided by a negative is a positive. Here, a negative divided by a positive is negative. Okay? So in the first quadrant, all trig ratios are positive. Okay? In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cosine is positive. So we went through this in math last year. So different textbooks have different acronyms that you can use. Just remember the properties. Where I do, all students take calculus. They don't all take calculus, but you guys are all registered to take calculus, so you can think about it that way. So all students take calculus, starting in quadrant 1. Some use the CAST rule, C-A-S-T. That starts in quadrant 4, so I think that's kind of weird. But when I was in school, that's what they did. Or if you're like me, add sugar to coffee. Okay, so that's another common one that starts with A. So, that, I think, because it's now getting near the end, we've kind of summarized it. So we're going to stop there, and then we'll finish the rest tomorrow and keep on going with unit circles. Okay? Okay, so we got to question 10. You may have worked ahead, that's awesome, but we're going to do it together to make sure you're on track. So I need no talking. Silence. So write each of the following in terms of the reference angle of the given angle. Use exact values. Okay? So, in terms of the reference angle, so think about, you might want to do a little diagram. Okay, so here, and then I'll do it blue. So here's my, oh, not what I wanted. Here, initial R, 230. Think where that's going to be. So 180, 230 here. Think of the triangle that's drawn. Okay, and if we're finding sine, we want the y value over the hypotenuse of that circle, or radius of the circle, hypotenuse of the triangle. In terms of the reference angle, that's this here, right? So, think about what is the SIGN of an angle in the third quadrant. Because there's sine and sine. One's SIGN, one's SINE. So is it positive or negative when we're finding the sine of 230? It's in the negative, right? So this is the same as, I'll just put it down here because I might run out of space, negative sine of the reference angle. So I'm going to put theta reference. In this case, the reference angle is 230 minus 180 is 50 degrees. So if you check that on your calculator, mode, degree mode, sine of 230 is negative 0.766. And if you put in negative sine of 50, no talking please, you should get the same. SIGN. Positive or negative, right? Just going to leave it like that. Okay? Cosine 5 pi over 6. So here, this. So 5 over 6. Is that close? Is that less than pi, 5, 6 pi, or greater than 5, 6 pi? Sorry, sorry. Is 5, 6 pi less than pi or greater than pi? Less. It's a fraction that's less than 1. Is it close to pi? Yes. So it's in this quadrant. Remember, think about your fraction. So it's going to be something like that. This is 5 pi over 6. Okay, we're finding cosine. So, is cosine positive or negative in the second quadrant?
Negative.
Negative. The x value is negative. Okay, so if we're writing this in terms of the reference angle, the trig ratios of all reference angles are going to be positive. So that means we want to take the negative of cosine of theta reference, which is, in this case, pi over 6. It is, yeah. So you could find that. We'll get into that in a little bit. I'm not going to bother finding it right now. 195, so that's in degrees. So you better know where that lies. So there. Okay, third quadrant. Third quadrant, we're finding tan. So in the third quadrant, is tan positive or negative? Positive. Because here, tan is the y over the x, so they're both negatives. The negative divided by negative is positive. So this is just equal to tan of the reference angle. And in this case, the reference angle, 195 minus 180 is 15 degrees.
So I was thinking the answer to there's an issue when supposedly it says tan of 5 degrees, which that doesn't make sense.
Yeah, that's an error. I blame Miss Sessions. She retired. Okay, so cosecant 2 is 2 degrees or 2 radians? Radians. There's no degree symbol. Okay, so that's radians. Okay, where is that going to be? So, I think we were talking about 2 radians.
No, again, we're talking about sine
one
of 2 versus sine of 2 degrees.
Yeah, so this is 2 radians. So remember, a complete, half a rotation is pi, which is 3.14. Half of pi is what, 1.57-ish. So this is in the second quadrant.
About 2/3 pi.
Yeah. So this is 2. Then, so our reference angle here, what are we finding? So this is the same as, so I'll put it here, 1 over sine of 2. So sine and cosecant, Bianca, let me just do this on top. So 1 over sine, or any of the reciprocal trig ratios are going to have the same properties as its primary one, because taking a reciprocal doesn't change a positive to a negative, or a negative to a positive, right? So here, cosecant, we want to be concerned of where is sine of 2, what SIG is it, SIGN. So in the second quadrant, it's positive, so this is going to be positive, so we don't have to really change anything, but in terms of the reference angle, equals 1 over sine of theta reference. So that's going to be the same. And what is the reference angle? Well, that is pi minus 2. And we'll just leave it like that. We want it as exact as possible. It says use exact values. So, yeah, you could go pi symbol in your calculator, minus 2, and then round it, but we'll keep it as exact as possible. Okay, now, do I have to leave it like that? Actually, I can just show it. I don't really have to show it as 1 over sine, right? I can just show it here as I just was doing this to remind you what it's equal to, but that's really showing it in terms of the reference angle. Cosecant pi minus 2. All right, so the next one, point negative 85 lies on the terminal arm of standard position angle theta. Determine theta rounded to the nearest hundredth of a radian or nearest degree. So basically here, we're going to do it in radians and then in degrees, right? That's all. So, gives you an actual point, which is nice. Graph it. So negative 8.5, maybe approximately there. So initial arm, terminal arm. So that's your theta. Okay. So draw your triangle. You can use, basically find this reference angle and then subtract to get theta. That will always work. Sometimes, remember, your calculator will only give you one angle out when you do the inverse of a trig ratio. It doesn't list them. There's an infinite number of them. So you have to think about it a little bit. In any case, so this is negative 8 and this is 5. But in that reference triangle here, so if we want to find theta reference, and we know these two sides, first of all, what trig ratio is the easiest? 10. Then you don't have to find the hypotenuse, right? If we're just looking this as a triangle, this would be 5, this would be 8, right? So the theta reference will be tan inverse of 5 over 8. Okay, that will give you your reference angle. So just check. We're doing it in radians here first. So convert to radians in your calculator. Second, tan 5 divided by 8. That's going to be, now, I'm not done yet, so I'm going to copy some of these down in case, for example, I clear my calculator by mistake. Okay, that's my reference angle. So theta is going to be pi minus the reference angle.
So pi minus 0.558. Now, hopefully you haven't cleared your calculator. You have it in there. So pi minus that answer is 2 point. Then it said nearest hundredth, right? Hundredth, so 2.58.
So did you see what I did? If I did, let's do it, if I included the negative, right? So let's go second tan 5 divided by negative 8. Okay? Notice how you get a negative value. That's because the calculator, so what that's giving you is a negative angle. It's giving you this one here. Let's round it, 0.59, basically.
That's accurate, but not for what we're looking for.
Correct. So that is a correct angle, but it's not, we're looking for the second quadrant based on the coordinates, right? So your calculator, unfortunately, will not list all of them. What it ends up giving you is the smallest absolute value of an angle, right? So the absolute value of this is 0.56. Oops, I put 0.59, so that's 0.56. It gives you that as opposed to this one, which is 2.58. Absolute value of that is 2.58. So it's always going to give you the smallest digit-wise, whether it's positive or negative. We're asked for the angle that has to be between 0 and 2 pi, so it has to be positive. Okay, so that's why I use the reference angle. You can do it like this, but you have to realize you're not done when you do this in your calculator, right? That gets you, because there's two angles that have a negative tan. Remember, this is all students take calculus. So negative tan are here and here. So it's giving you one of them. We wanted this one. Okay. Sometimes you'll be asked to give all of them, but not when you have a point. There's only one place that negative 8.5 can be. Okay? Now, do I have to do all that work again to get it in degrees?
No, it's inverted.
Just convert it. Okay? So, if you want to, you can, but I wouldn't. I would use the unrounded, right? So now theta is equal to 2.5. I'll use the rounded in here, but I'll use my unrounded in my calculator. So I go back up, okay, multiply, take that, multiply by 180, divide by pi, and we get 140, what is it, nearest degree, I think? Nearest degree, yeah. 148 degrees. Okay, again, second quadrant, makes sense. So always check that. Right? Because your calculator is good, but it doesn't do everything for you. You actually have to know some stuff. Back in the day, we didn't have calculators, or we weren't allowed calculators. We had them, we weren't allowed them. So for trig, we would have trig guides at the back. We would have trig tables. So it would give you look at for your angle, and then cross to sine, or cosine, and it would give you value.
What if it wasn't exactly?
Well, you can do it for all, right? And give you a table. Pardon?
Now you can't.
Now you can.
God, I love technology.
Yeah. Same with log tables, logarithms. Yeah. Even when I was teaching, even when I moved here, in the 30-1, we had for, now it's in 20-2, normal distribution. So we'll be doing that
this year. Or no, did we do it last year, normal distribution?
Yeah, we have the
Yeah, we did. So that we had tables for, because we weren't allowed to use a calculator.
Yeah, why, so they don't teach that in dash one, but that's part of the ID curriculum, right?
Correct.
Yeah.
Okay, so this one, now we're not given the, it as a fraction, we're given it as a decimal. Doesn't change anything, okay? So we're given a trig ratio as a decimal. So we need to think about, now we have choices, because we're not told the coordinates, we're told the ratio. So if we do a little diagram here, think about, so all students take calculus, sine is negative, so I always just put a star where I think it's going to be with quadrants. Okay, so based on that, it's quadrant 3 or quadrant 4 angle. The reference angle for theta would be finding the inverse of always the positive. Because remember, a reference angle is always less than 90 degrees. So doing that in your calculator. Now, got a degree symbol here. So mode key, I've got to change my calculator back to degree. And then go second sine, 0.5341. Doesn't say what to round to. I'll go to 1 decimal place. Okay. All right, so then it says determine all values of theta rounded to the nearest degree. Okay, so nearest degree, this would be 32 degrees, right? Such that theta is between 0 and 360. So we found the reference angle, 32. That's not your answer in part C. Because we need to find theta where the sine value is negative. So that would be in this quadrant and this quadrant. So your reference angle is 32 in each of these. That means your actual angle to here is 180 plus 32. And then from here to here is a 360 minus 32. Okay, so that's going to be 212 and 330, 328. Now, you can check. You go, now it won't be exact, but you can check the sign. So if I go sine of 212, I get negative 0.5. See how it's fairly different because I've rounded to the nearest whole number. What's important, though, is that it's negative, and that's negative up there. If it was far off, then obviously you got the wrong angle as well. But and then sine of 328 should be the same as that. Okay, so solving, we're going to do more solving trig equations a little bit later in the course. These are your basic ones, right, where it's just a trig ratio. That's it. You don't have two terms, you don't have trig ratio squared and all that kind of stuff. Pretty basic. So it says solve for theta rounded to the nearest hundredth of a radian or nearest degree given the indicated restrictions. So here, this tells you that you've got to be in radians, because there's no degree symbol, right? This one, your answer is in degrees. This one's in radians, this one's in radians, etc. Okay, so tan theta equals negative 3 over 2. So then I think, okay, where is tan negative? So all students calculus. So tan is negative here and here. Okay. So then we're dealing in radians. So I'm going to think about the reference. So theta reference will be the inverse tan of positive 3 over 2. I'm going to change my calculator to radian mode. Okay, and then second tan, inverse tan, 3 divided by 2. And nearest hundredth, so 0. I'm going to show it, 9, 8, 2. I'll go to 4 decimal places and then round 9, 8. But that's my reference. Okay, if you just leave it like that, you got it wrong, right? Because you want it in the second and fourth quadrant. So something like that, and like that. So this is 0.98. So your theta, the second quadrant, we're going to go pi minus 0.98. Figure out what that is. In the fourth quadrant, 2 pi minus 0.98. Try not to use the 0.98. Try to use it in your calculator. Okay? So pi minus that answer. Now we can go to the nearest hundredth, 2.16. 2 pi minus that is 5.30. Okay, so those are your solutions. There's 2 between 0 and 2 pi. So in a rotation, there's always 2 solutions unless it's a quadrantal angle. So on the axes, sometimes it's going to be, depends on the angle or the trig ratio, it'll be just 1.
Sometimes they're like not necessarily like for example, sine of
Oh, well, yeah.
tan of 90 degrees.
Right. I mean, these were finding the angle, so, yeah. Not really gonna have to worry about that yet.
Yeah, no, tangent of theta equals undefined, like.
Then you know, right? Then it's 90. Okay, secant. So what I recommend, because there's no secant button in your calculator, right? So remember, secant, remember secant is equal to 1 over cosine, right? So that means 4 equals to 1 over cos. So cos equals 1 over 4. You don't have to show all those words, but you can just go right to that. Take the reciprocal. Okay, so then you can use your calculator. Now, this is positive. We're in degree mode, so draw. I always draw. You don't have to. I just like to think about it, right? I don't try to zoom through. I try to think it through. So 1/4, that's positive for cos. Well, cos is positive in the first quadrant and the fourth quadrant. Okay. So, I mean, you can, that's 1 and 4 there. If it's given to you as a ratio, you could label it if you wanted to. In any case, we don't care about that. We want to know what the angle is. So this is in the first quadrant. So it's going to give us our reference angle and one of the angles we need. Right? That's kind of nice. So theta equals, theta reference equals cos inverse 1 over 4. This is degrees. Did I change it? Gotta change it back to degrees. And then second cos 1 divided by 4.
Okay, 75, 75.52. Okay, it does say round to the nearest whole degree. I'll do that in a sec. That's going to be the same as theta. And then, so theta is going to be equal to that. And because actually it's degrees, we don't have to keep the decimals because it's not like pi, right? So it says nearest degree. So theta will be, that actually goes to 76 degrees. And then this angle all the way to here will be 360 minus 76. So therefore, theta equals 76, and what is that? 284.
Do you care how we write our solutions? Like, we just missed them, or?
Yep. Okay, next one tells you cos is negative. What it also tells you is sine of that same angle that gives you this cos gives you a positive value. So maybe that's going to narrow down. Maybe you're only going to have one angle that works. So again, correctly. So cos is negative. Where is it negative? It's negative in the second and third quadrants. And sine has to be positive. So then, where is sine positive? In the first and second. This one's the winner. Okay? Where it overlaps. So now I know I only have one answer. It's between 0 and 2 pi. Because both of these have to be true. So I'm only looking here. Right? Okay, and again, I'm going to go theta reference will be cos inverse of positive 2 over 7. Dealing in radians. So, second cos, everything divided by 7, 1.2810. Okay, so my theta is pi minus that. Pi minus that. 1.86. Okay. One of them. I don't care about the third quadrant because sine is not positive there. You don't have to. It's just showing you that's a set of solutions. Now, if I had yep, but I found a reference angle. Now, if I did second cos negative 2 over 7, I do get the same answer. Okay? That's because that's the smallest absolute value. Right? Actually, absolute value of this one would be the same, but it would go to positive first. So as I said, sometimes your calculator will do it, but remember with tan, it gave you this one in the fourth quadrant because it was smaller than this, the absolute value. So sometimes, again, you can get away with not talking about the reference angle, but sometimes you can't, right? It really depends on what trig ratio and what angle. The sign, positive or negative, that kind of thing. Okay, so cosecant is the reciprocal of sine. It's a positive value. So where is sine positive? In the first and the second. Secant is the reciprocal of cos. Where is cos less than 0? That means negative. Cos is negative in the, I'll just use color, in the second and the third. So where do they overlap? In the second quadrant again. Okay. All right, so again, you don't have a cosecant button, so this will be the same as sine theta equals 1 over 3.9812. You can do that in your calculator. Okay, just leave it in your calculator. And so then theta reference will be inverse sine of 0.2518. So it's in my calculator, second sine of that answer. Yeah, and it's asking for degrees. Good. Okay, so now my theta will be pi minus that. Rounded. Okay, and again, only one solution because of the two properties that are given there. Now you can see if I had done, well, yeah, that's positive anyway. So if you had just done this here and left it, you would have got it wrong. Right, because that's the reference angle. That's in the first quadrant. Remember, there's two that give you a positive sign. So, and then another thing, say, I don't know, you forgot that cosecant was the reciprocal of sine, and you went second, or you forgot, yeah, you just did sine for some reason, of 3.9812. You get an error, right? If you go to the go-to, it'll flash on the bracket there. It doesn't like that number in there. Why doesn't it like it?
It's greater than, or it's greater than 1, yeah.
Bigger than 1. Remember sine ratios, because it's the opposite over hypotenuse. The opposite in a triangle can never be bigger than the hypotenuse.
Greater than 1 or less than greater than 1.
Yeah. So that's a clue to yourself. Oh, I got to do something first. I can't take find the angle. There's no sign that will have a value of 3.9812, right? Okay, so kind of get the gist of that, I hope. I'm going to leave E and F for you to do so we can get into the next set of notes. So I'm going to